All right, this is 4.4. We are going to be graphing square roots and um, cubic functions. So we've graphed x squared functions, and the normal x squared graph is right here. And then we go over 1, up 1, over 1, up 1, and over 2, up, do you remember? 4. So 1, 2, 3, 4. And the reason is, if we build the xy graph, y equals x squared, 0 squared is 0, 1 squared is 1, negative 1 squared is 1, 2 squared is 4, and negative 2 squared is also 4, positive 4. Okay? And then we learned if we had y equals x minus 3 squared plus 2, what does that look like? So the inside is backwards. So right 3. So 1, 2, 3, and up 2, 1, 2, right there. And then we do the same pattern. Over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4. Okay? So what if I put a number in front, like 3? What is that going to do to the graph? It's going to triple all of the y values. How do I know it affects the y-axis? Because it's outside the parentheses. Anything on the inside affects the x's, anything on the outside affects the y's. So that would make it 3 times taller. What if I times it by 1/2? What would that do? It looks wider, but the actual movement is shorter, because we're going to take the y values and times it by 2. So this graph does look wider, but it's actually smashed vertically. It's half as tall. Is half as tall and twice as wide, are those two things equal? Not usually. Sometimes they are, but most of the time they're not. So we have to focus on, are we moving the x's or are we moving the y's? So here we have a cubic graph, and if I had x and x to the third, 0 is going to be 0, 1 is going to be 1, so over 1, up 1, and negative 1 is going to be negative 1, so over 1, down 1. What about 2? Well, 2 cubed is 8. So 2, 8, way up here. What about negative 2? Negative 8. So it's going to be way down here. So the graph looks like this. Okay? It's sort of like a skinny parabola where half of it has been flipped upside down. So if this is my parabola, it's sort of like a skinnier parabola, but this side has been flipped upside down, and it's that way. Why is the left side down instead of up? It's a cube. And if you cube a negative, it remains negative. Okay? All right. So how do we do this problem? So it's x and negative 9 over 8 x to the third. Well, 0 is still going to be 0 right there, right? What about 1? So we stick 1 in there. 1 times 1 times 1 is 1, and we get negative 9 over 8. So negative 9 over, so it's going to be negative 9 over 8. I could use this button, and I could graph 1 comma negative 9 over 8. Right? But what about 2? So 2 times 2 times 2 is 8. So I get negative 9 over 8 times 8. The 8's cancel, and it's just negative 9. What about negative 1? going to be 9 over 8. What about negative 2? It's just going to be 9. Right? So negative 2, 9 is right there. And then negative 1, 9 over 8 is going to be right there. And then 1, negative 9 over 8 is there. Oh, sorry, there. And then negative 2, or sorry, positive 2, negative 9 is right there. And those are my 5 points. Do you need to see another one of those? No? All right. All right, what about a square root function? Well, an x squared graph is over 1, up 1, over 2, up 4. That is an x squared, so a square root is sort of the opposite of that. It's the inverse of that. So if I wanted to graph a square root, it would be up 1 over 1, and then up 2 over 4. That is what the graph of a square root looks like. Okay? So what if I had x minus 3, or the square root of x minus 3 minus 4? Where is that graph going to be? Over 3, so here, and down 4, right here, and then it's going to look like that. What is the domain of this function? Which x's hit the graph? Everything from 3 over. Does 3 have a part on the graph? Yes, it's right there. Does 3.5? Yes, right there. Does 10? Yes, right there. Does 2? No. So we would say x is greater than or equal to 3. Okay. How do you find that without graphing it? Well, we just set the stuff on the inside greater than or equal to 0. Did this negative 4 affect the domain? No, all it did was change the height. So if I take the stuff on the inside, x plus 5, I know that that cannot be negative. If I plug in a number that makes x plus 5 negative, then I can't graph an imaginary number. So I know that x plus 5 must be greater than or equal to 0. So I subtract 5, and I get x is greater than or equal to negative 5. Okay. What if my equation was the square root of 2x plus, no, let's do 4 minus 2x minus 3. What is the domain? Well, the negative 3 has no effect on the domain. And I know that this cannot be negative. So 4 minus 2x must be greater than or equal to 0. So I subtract 4. Negative 2x is greater than or equal to negative 4. Divide by 2, and I get x is greater than or equal to 2. Right? Wrong. What did I do wrong? I have to flip that. Why? It's because I divided by a negative. Why is that the case? Well, let me show you. If I had 2x equals, not 0, 4. So I have a balance. I have 2 x's, and I have 4 1-pound rocks. I can do anything I want to this equation as long as I do the same thing on both sides. So let's get rid of half of the x's and half of the rocks. Is that balance still true? Yes. So how much does an x weigh? 2 pounds. All right. What if I had 3x minus 1 equals 5? Okay, so I have 3 x's and I have 5 rocks, what is a -1? It's sort of like a balloon pulling up that weighs a pound, right? Okay, so how do I get rid of that balloon? Well, if I eliminate 1 upward pound, how do I keep this balanced? I could get rid of 1 downward pound on the same side, or add a downward pound on the other side. And now get rid of 2/3 of them, and I get x equals 2 rocks, right? Okay. What if I had negative x equals 3? So I have an x balloon pulling up that is equal to, let's do this. Let's do -3. So how much does x weigh? Well, I know that negative x is equal to -3 rocks, but if I times this by -1, what's going to happen? The balloon turns into a weight, and these balloons turn into 3 weights. So x weighs 3 weights, 3 pounds. Okay, but what if I have -2x is greater than -4? Okay. So which side is heavier? The left side is heavier, right? This is no longer a balance. Over here, I have 2x balloons. And over here, I have 4 1-pound balloons, right? So the right side is pulling up harder than the left side is. Agreed? So what happens when I divide by -2? I'm going to get rid of half of the weights, right? So that goes away, and those go away. What else am I doing? Now the x changes from a balloon to a weight. And now my 1-pound balloons turn into 1-pound weights. So which end is stronger? If this was pulling up harder than this side was, then when I flip it, this side is going to be pushing down harder than this side is. But you have to flip the inequality. Does that make sense? If it's an equality, you don't have to worry about it. 4 pounds up and 4 pounds down are going to balance. If you have 4 up and 4 up on one side, you're balanced. If you have 4 down and 4 down on one side, then you're balanced. But if the equation is inherently unbalanced, then changing the sign is going to flip the inequality to the other side. So if your right side is light, when you times by a negative, your right side is now going to be heavy. So this becomes x is less than or equal to 2. That was a really long explanation. All right, here we're just going to plug in numbers. So the cubed root of 62 plus 2 is the cubed root of 64. So I break that down and I get 2, 2, 2, 2, 2, 2. I'm looking for sets of 3. I have 2 sets of 3. So I can bring 1 out for each of those. And I get 4 with nothing left on the inside. Okay. The next one, cubed root of -10 plus 2 is the cubed root of -8. 2 to the third is 8. What about the negative? Can you cubed root a negative? Yes, you can. So this is just -2. No i's. Okay, graphing a square root. Where is this going to be? Left 1. So it starts here, and then instead of right 1, up 1, and right 2, up 4, it's up 1, right 1, up 2, right 4. The leftmost point and 3 additional points. So up 3 over 3 times 3 is 9. So up 3 over 9. Here we go. Okay, what is the domain of this? I know that the inside cannot be negative. So negative 8x plus 8 is greater than or equal to 0. Negative 8x is greater than or equal to negative 8. Divide by negative 8, and I get x is less than or equal to 1. Remember to flip that inequality. All right. This is a basic absolute value function. What is the plus 3 on the inside going to do? Move it left 3. So here is my graph. Okay. What is the negative 2 going to do? Now, if I had minus 2 over here, that would be down 2. We're going to multiply by 2, by negative 2. So all of the y values get multiplied by negative 2. So this point right here is negative 2 comma 1. Oops. So we're going to multiply this by negative 2. So that becomes negative 2, negative 2. Oh, I better move my graph back up. So negative 2, negative 2 right there. This point is negative 4 comma 1. I times this by negative 2, and I get negative 4 comma negative 2. So negative 4, negative 2. This point is negative 5, 2, times this by negative 2, and I get negative 5, negative 4. So negative 5, negative 4. And you'll see it appears skinnier, but we didn't move the x's, we moved the y's. So it's upside down and twice as tall. So if this is over 1 up 1, over 2 up 2, over 1 down 2, over 2 down 4. All right. Let's find the domain of f. So in a cube, in a fourth root, the inside cannot be negative. So x plus 5 must be greater than or equal to 0. So we subtract 5, and I get x is greater than or equal to negative 5. But this time it doesn't want me to give the answer in inequalities. It wants to give me an answer in interval notation. So if I were to graph this, it would be a closed circle at 5, and we would shade to the right. Okay? In interval notation, it's always bracket or parentheses, low, comma, either bracket or parentheses, high. So this means equal, and this means not equal. So what is the smallest number in that set? Oh, it should be negative 5, sorry. Negative 5. Does the graph exist at negative 5? Yes, it's equal to. So I picked this one. What is the highest number in that set? Infinity. Does the graph exist at infinity? No, we can't reach it. So infinity always gets a parenthesis. So let's say I had 2 to 6, and I shaded in between. What would that be in interval notation? So bracket 2, comma, 6 parentheses. Okay, so equal to always gets a bracket, not equal to or open circle always gets a parenthesis, and infinity always gets a parenthesis. Okay, what if I had the fourth root of 3 minus x? So 3 minus x must be greater than or equal to 0. Subtract the 3, divide by -1, and I get x is less than or equal to 3. So what does that look like? That would be a 3 with a closed circle, and we would shade to the left. What is the smallest number in that set? Negative infinity, parenthesis or bracket? Parenthesis. And 3 gets a bracket. Now, how do I tell the difference between the point 1, 2 and the interval from 1 to 2? Because they use the exact same symbols, right? So a point will always have a name like P or A, okay? And then an interval will say x equals. So if x equals parenthesis 1, 2 parenthesis, that means all of the numbers bigger than 1 and smaller than 2. If there is a point, and points are usually capital letters, and x's are usually lowercase letters, that's how you tell the difference. Okay. Not in this case. It's so when it says domain of f, that's kind of a hint that it's an x, even though you don't write the x. What about this? What is the domain of that? Are there any numbers we can plug in that will break the function? Let's plug in 0. 2 times 0 minus 4 is -4. Can I take the cubed root of -4? Yeah, cubed root. If it's a cubed root, I don't have to worry about i's, right? So what is the domain of that? Everything. Yes, so that graph looks like this. It's an x to the third graph that has sort of been reflected and now it's sideways. Are there any x's that do not exist? No. This x exists here, this x exists here, this x exists there. They're all there. So that would be this. All numbers bigger than negative infinity and smaller than infinity have a place on the graph. Okay. So where is this? Left 3, up 1. So left 3, up 1. And then the pattern is up 1 over 1, up 2 over 4, and up 3 over 9. Like that. Okay. What if I put a negative out front? How is that going to change it? Is it going to go down or is it going to go left? Well, it's on the outside. Does the outside affect the x's or the y's? The y's. The x's are inside, so it's going to look like this. How would I make it go left? You would make the x negative, and then it would go to the left. All right. Graph a cubed root. So this is left 2. And normally it's over 1, up 1, over 2, up 8. But since it's a cubed root, we go over 1, up 1, over 2, right 8. Down 1, over 1, down 2, over 8. Like that. Okay. That's it. get to work.